The range card, sometimes called a cheat card, is an essential tool for use in long-range shooting. This card was prepared for a .308 caliber with a muzzle velocity of 2,635 feet per second, 2.6-inch sight height, in an atmospheric condition of 500 feet altitude, 59 degrees Fahrenheit, 78% humidity, standard barometric pressure. Ideally, a specific range card should be prepared for each atmospheric condition that the shooter may experience. In the simulation, all range cards for each caliber are created for a standard day, 500 feet altitude, 59 degrees Fahrenheit, 78% humidity. The shooter will need to mentally adjust for extreme temperatures or altitude. In this way, the effect of atmospherics on the bullet is graphically displayed. The elevation and windage values for this simulation were calculated using Sierra Infinity 5 exterior ballistics software. The elevation is rounded off to the nearest quarter minute for ease of use. The wind drift given in inches is calculated to the nearest tenth of an inch for a 1 mile per hour full value wind, 9 or 3 o'clock. Therefore, if you have a 5 mile an hour wind at any range, the wind drift in inches needs to be multiplied by 5. A 10 mile per hour multiplied by 10, etc. Since the wind drift is in inches, the final value needs to be converted into minutes of angle in order to adjust the scope setting. Therefore, for a 5 mile per hour wind at 700 yards, 4.3 times 5 equals 21.5 inches. Convert 21.5 inches to a minute of angle. 21.5 divided by 7 equals 3.1 minutes of angle. At 700 yards, 7 inches equals 1 minute of angle. 3.1 minutes is the windage value. For a quarter minute scope, this would be 12 clicks. It requires a little more math to determine elevation or windage on ranges in between the ranges shown. In the following example, an elevation and windage value will be determined for a target at 730 yards with a 10 mile per hour wind. 730 yards, 10 mile per hour wind. The value could be obtained by getting a ballpark value. Let's see. 730 is a bit more than 725, which is halfway between 700 and 750. So the elevation is about 20 plus a little more. Let's say 21.25. And the wind drift is a bit more than 4.6. So let's say 4.7 times 10 is 47 inches. To get a more accurate value for the wind, 5.0 minus 4.3 equals 0.7 inches. 30 divided by 50 equals 0.6. 0.6 times 0.7 equals 0.42 inches. 4.3 plus 0.42 equals 4.72 inches. 4.72 times 10 equals 47.2 inches. 47.2 divided by 7 equals 6.74 minutes. 6.74 times 4 equals 27 clicks. The range card gives a wind drift at 4.3 inches for 700 yards and 5.0 inches for 750 yards for a 1 mile per hour full value wind. To get an exact wind drift for 730 yards, divide 30 yards by 50 yards to get 0.6. This is a proportion of the 50-yard spread. Multiply 0.6 times 0.70 inches, the difference between 5.0 and 4.3, and you get 0.42. Add 0.42 to 4.3. The windage is 700 yards to get a value of 4.72 inches of drift for a 1 mile per hour full value wind at 730 yards. For a 10 mile per hour wind, multiply 4.72 times 10, which gives 47 inches of drift at 730 yards. To calculate the minutes of wind, divide 47 by 7.3. 1 minute of angle equals 7.3 inches at 730 yards. To get an exact value of 6.74 or a 7-minute wind. The ballpark estimate was pretty close, in fact right on. With practice, the tedious math calculations won't be necessary. 4.7, so let's say 4.7 times 10 is 47 inches. 4.72 times 10 equals 47.2 inches. The range card gives a wind drift you would expect that the wind drift for half value winds to be half of the full value, but that isn't the case. The chart shows the wind drift in inches for a 10-mile-per-hour wind at 600 yards at different directions. Standard day 308, 175 grain. You would expect the drift at 1:30 and 4:30 to be half of the full value drift of 28.90, but it's more. This is because the wind is at an angle. Trigonometry comes into the formula for determining the wind drift for half value winds. The full value wind drift is multiplied by the sine of the angle of the half value wind. The actual values are slightly different due to the component effects of head or tail winds. The simulation used a half value wind, so for accuracy multiply the full value amount by 0.707. The lead-in mills is available on the range cards on ranges with moving targets. The value is for a walking target at 3 miles per hour.